S. Chand presents Educational Video Lectures as per the AICTE curriculum. Difficult concepts made easy. Study anywhere, anytime.
So in this lecture, we'll be learning beta and gamma functions. In the previous lecture, we learned improper integrals. Both the functions are improper integrals. Beta is also improper integral and gamma is also improper integrals. In beta, you will see finite limits, but when you will substitute the limits for some, the way the function is defined, it is unbounded for the limits 0 and 1, but we have the calculation and the function is very, very important. So, we will see how it is defined and how it is useful. Then gamma function limits are from 0 to infinity, but this also is improper. It seems to be, but it is convergent. We know the concept of convergence and divergence for improper integrals. This we did in our previous lecture. So, in this lecture, we will be learning beta and gamma, how they are defined, and their properties even we will be learning in this part. Hello everyone, I am Dr. Seema Thakran. If you want to know the concept in detail, please refer to the book by S. Chand Publishing. The e-book link is given in the description box below. First I will discuss beta, then I will come to gamma, and then I will connect the relation between both. So, beta function I will start with. Beta function is, I will name it, this is beta, and the naming is beta mn. It means the parameters are m and n. And the point is that the function will depend on m and n values, that is why they are parameters, and it is defined from 0 to 1, x to the power m minus 1, 1 minus x to the power n minus 1, this. If I am not putting any condition on m and n, you see when I am substituting 1, so 1 minus 1 0, if suppose this value is negative, it will become improper integral. If I am substituting 0 and m minus 1 is negative, it will become improper. So, I put a condition, and the condition is that m and n are greater than 0. So, you can say, in other words, so m and n both are greater than 0, or in other words m and n greater than equal to 1, both the same, both the expressions are same. Now, beta mn is this. There is very important property, and the property is that if you change m and n, there will be no difference in the function. And the point is that if you change 0, I am just changing the variables in the beta function. There will be no change, just replace x by 1 minus x and it will come out to be exactly same. It means you are calculating beta mn or beta nm, it's just the same thing. You can see also, if I just let 1 minus x equal to t, minus dx will be dt, dx will be minus dt, and now change it. So, x value will be, you just see the property how it is true. So, x value will become 1 minus t. So, 1 minus t to the power n minus 1, and 1 minus x is t, m minus 1. My dx is minus dt. See the limits? When you are substituting 0, so t limit is 1. When you are substituting 1, t limit is 0. And just whenever we change the limits, we put a negative sign, and we have negative. So, I am just changing the limit to make it to look or to make it same. So, 1 minus t n minus 1 dt, and you can see this is exactly beta mn. So, I started with beta nm and I have reached to beta mn. I started with beta nm and I have got that beta exactly it is same as beta mn. So this is very useful property. So we'll remember it, beta mn is beta nm. So there is another useful form also of this beta function, and that form is, this is the form we have just seen, and what I'll do, I just let x as sine square theta. Very important result we'll get from this. X is sine theta, sine square theta. So dx will be what? 2 sine theta cos theta d theta. And beta mn is, now when you are substituting, when x is 0, theta will be 0. When x is 1, sine theta 1 means theta value is pi by 2. And x is x to the power m minus 1, x is this, sine square theta. So x to the power m minus 1, and 1 minus x means 1 minus sine square theta to the power n minus 1. Put the value of dx also. Dx is 2 sine theta cos theta d theta. Merge the values. So this is 0 to pi by 2 sine to the power 2m minus 2, because square we have, so 2m minus 2. There is 1 sine theta also, so I am just adding the plus 1, because we can add powers. If the exponent is same, we can add the powers. And take this, keep this 2 outside. Now same thing, 1 minus sine square theta is cos square theta. 2 the power n minus 1 and 1 cos theta we have, and d theta. So it is twice 0 to pi by 2. The limits are from now 0 to pi by 2, twice sine 2m minus 1 theta cos 2m minus 2 and plus 1 d theta. So this is my expression. It means we can represent beta function in two ways. Whichever form is useful according to the question, we can use accordingly. So this is beta mn. You will not get to know the useful use of this beta, because I have just given you the forms. I will introduce another function, that is gamma function. Then I link up, and then you will see how it is making our calculation simple. So my next is, beta function is done, and now gamma function. So gamma function, the notation is, it's just t, but just this is the way we write. This is the notation gamma, and gamma of n 0 to infinity e to the power minus x, x to the power n minus 1. Here also, if because 0 to infinity, it seems, because I told you that this is improper, because a limit is infinite, infinity it is, and I am putting again a condition n is positive. It means n is greater than equal to 1. When n is greater than equal to 1, it will be always positive, and when you will calculate it, it has value. It is anyhow convergent integral, because if you are saying gamma function is this, and if it is useful, obviously it should converge, because only convergence can help, divergence cannot help. So this is gamma function, and for gamma, so gamma of 1, first we see what is gamma of 1. Here the parameter is n, I hope, because parameter is very important. It means the complete function is depending on n. Gamma 1 means n I am substituting as 1. So 1 minus 1, it means 0. So this is simply this, e to the power minus x integration is e to the power minus x minus 1, 0 to infinity. E to the power minus infinity lower limit minus and this minus will become plus. So, put the limits e to the power minus infinity by minus 1. Lower limit minus and this minus will become plus 1. 0 when you are substituting. E to the power, okay. For log, I have already told you the formulas in my previous lectures. E to the power infinity, this also you can note down. E to the power 0 is 1, e to the power minus infinity is 0, e to the power infinity is infinity. Anyhow, log and exponential functions are inverse of each other's. Formulas have come from log concept, you can say, because they are inverse of each other. If you know log values, you can calculate exponential values. If you know exponential values, you can calculate the log values. E to the power minus infinity is 0 plus e to the power 0 is 1. So, finally, we are getting it as 1, the value of gamma 1. I told you this gamma function is defined for n greater than equal to 1. That is why I started with the very first value gamma 1 equal to 1. Then I have two formulas, and anyhow for BTech Laplace transformation this formula gamma function is very useful, and some of the formulas totally depend on gamma function. So, the formula is n gamma n is n minus 1 factorial, and there is another formula also. Both the formulas are different and can be applied in different situations. And what are those conditions? I am just mentioning. When your n is integer, you use this formula. N is integer. It means gamma 1, 2, 3, 4, 5. Now you can see if I am calculating gamma 2, it is just simply 1 factorial, that is 1. Gamma 3 means 2 factorial because 3 minus 1. So, all the values you can easily calculate by this formula. This you use when n is fractional number, or you can say when n is in fraction. So, different formula and different for different values you apply, and this is how you use. So, this is end of this part, and in this part we have learned beta and gamma functions, how they are defined, what are the values and their properties we have learned. If you want to know the concept in detail, please refer to the book by S. Chand Publishing. The e-book link is given in the description box below. Please like, share and subscribe S. Chand Academy. Don't forget to press the bell icon for the future updates. Stay connected, stay tuned, keep watching upcoming videos. Thank you.
All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.